Hello, everyone. This is another lesson in continuation with the using the SUVAT equations in solving real world situations and solving the numerical problems in our related topics in physics. So here in this part, we are going to study about the upward motion in uniform gravitational field. When we talk about upward motion in uniform gravitational field, it means the object is moving upward. If this is the earth and the objects are falling freely, so all the objects are attracted towards the center of the earth. So whenever we consider the motion of an object towards the center of the earth, it is considered as positive. Okay, but whenever an object moves against the force of gravity, it is considered as a negative motion, and this motion is called upward motion, which is occurring against the gravitational force. So against the gravitational force, if an object moves upward, the motion will be considered as negative because the direction of motion is opposite to the direction of force. And here, the gravitational acceleration will be with a negative sign. Okay, so when objects are thrown straight up in Earth's gravitational field, they experience a uniform acceleration towards the ground. This is the same as negative acceleration in their direction of motion. So when we use SUVAT equations, we can describe the motion of such objects. For example, a ball is thrown upward with a velocity of 5 meters per second. That means the ball is given with an initial velocity of 5 meters per second. What height does it reach? So we need to find out the displacement or the height the ball reaches. It means we are considering only a one-directional, unidirectional motion, that is only the upward motion. So how to solve this part? We can solve this part by listing the required SUVAT values. We know that initial velocity is 5 meters per second. The height is to be calculated, and the final velocity at a certain height, for example, the object is thrown here at a certain height, at the maximum height, the object will be at zero velocity. Okay, so here the object will stay for a second or a fraction of a second before returning towards the ground. So the final velocity here in this one directional motion is 0 meters per second. And what will be the acceleration? The acceleration will be considered as negative g, which can be taken as minus 10 meters per second square. What do we need to find? We need to find h, and h is the height. So we can replace s with h. We have two equations which are using the distance or the height. So the one equation is this. Now this is the equation for rectilinear motion. We can convert it to free fall motion. The equation for free fall motion will become like this. Okay, and the another equation was 2as is equal to v square minus u square. So we can use this equation as well. Here for the free fall motion, we will make it a will be replaced with g, s will be replaced with h, v square minus u square. So I think this is the better equation. This is the equation which we need to solve this problem, because we are not discussing about time here. So we do not have time here. We will rearrange and use this equation. So to use this equation, 2gh is equal to v square minus u square. So here we will write 2, putting the values or substituting for g, it will be minus 10. Height is to be calculated. Final velocity is 0 and initial velocity is 5. So it becomes minus 20h is equal to minus 25. This minus sign and minus sign will cancel each other. It will become 25 divided by 20. And what will be the height of the object? the object reaches 1.25 meters above the ground level. Okay, so was it easier? Thank you. This was another situation when we are dealing with upward motion in uniform gravitational field. This is how you can apply SUVAT equations in solving the real world situations. Another situation, that downward motion, upward and downward motion in uniform situation field, will be discussed in the next lesson. So stay tuned. Thank you.